Welcome to Tube Time on Cool Dude Clem's Electronic Workshop. So here we can see a closer look at my preamp using a valve. Now if you're wondering what this thing is, this is one of the power supplies. We'll go into that in just a little while. Anyway, we're going to test, not taste. I mean, if I tried tasting some of this, I'd zap myself. But let's take a look at some of the voltages here. I hope you can see the meter, because no matter where I put it, it's always glaring somehow. So anyway, let's take a look at the supply voltage, which we've got right here. We have 225 volts. Let's test this plate here, which is connected here. You might hear a few crackles and pops while I'm doing this. We have 124 volts on that plate, which is the first plate. And now we're going to test the voltage of the second plate, which is connected to this capacitor here, and then that goes out to the laptop. So on the second plate we have about the same, 120, almost 126 volts. So that's biased, nice and good, because we got about half the supply voltage there. And of course, the filament supply, as you can see, is about 6.4. And I've got a 12 volt supply here, which is reading just under 12 volts, which supplies this microphone with phantom power. And this big variable resistor here, that's the gain control. And in the previous clip I had that set a bit too high and it was overdriving, but it should be alright now. Anyway, enough of that, time for some schematics. And here is the schematic of the preamp that you were just listening to, and as a matter of fact still are. As you noticed, I've drawn the version that's for use with a capacitor microphone here. But if you're not using a capacitor microphone, if you're using a dynamic microphone, let's say a moving coil microphone, you can omit this resistor here and just connect that cathode directly to ground. Get rid of this 12 volt supply and this resistor here, because you won't be needing to use those, and it'll work just fine. that resistor there is just to lower the gain a little bit when using a capacitor microphone, because these kind of microphones do have a little bit more output than a standard moving coil. Anyway, there's one very small change that I couldn't really avoid making, and that's this 470k variable resistor here. I thought I had a few spare in my stock, but I don't, so I had to use a 47k instead. But it doesn't seem to affect the amplifier's performance. It still seems to work, so even though just one component is different to what I wanted to use, it still seems to work just fine. And I had to do quite a few revisions of this. I think this is like the third, because when I first made this, there was so much gain you would not believe. I was just overdriving everything it was connected to. It was ridiculous. Now I know there's a couple of extra components for when I connect this to my laptop, so let me just draw those in. So from the output, I've got a resistor here, like this. For 100k. It looks more like 166k, but that's 100k. I know, I'll put a strike through the zero like an old computer, then you can see that it's actually 100. And then, running out of space here, a capacitor there, at 10 microfarads. Well, that's the positive side of the 10 microfarad, and then that goes off to this connector that connects to my laptop, like that. And these two boxes here, well, these are the two power supplies. So let's take a let's take a closer look inside this one, because this is the more interesting of the two. So this is the high tension or high voltage, or whatever you want to call it, power supply. Basically, this is the power supply for the anode part of the circuit. Seems crazy, all this stuff just to power up one tube, but it's worth it. So anyway, let's go from here where the power goes in to here where the power goes out. So firstly, we've got two transformers, and these two transformers are exactly the same. The only difference is that this one is mounted vertically, whereas this one is mounted the other way. So mains goes into this transformer, and I can switch that on and off via this switch here. There is also another couple of wires going off this switch, shorting out this resistor, and I'll go into what that is, to why that's there later on. But anyway, so we get 240 volts going in this side, 12 volts going out that side. Some of that also goes into this relay, which I will also explain later. But anyway, the rest of that 12 volts goes into this transformer and comes out again at mains voltage. So, 240 in, 240 out. Completely isolated. Anyway, the output of this transformer goes along this cable here and out to the connector on the end, which you should be able to see. There's a connector there, and also the output from this transformer goes into this resistor and then into this rectifier here. And I did look that up to make sure it can handle the voltages, and it can, as well as the capacitors. So anyway, that gets rectified by this little rectifier here, that gets smoothed by this capacitor here, and then further smoothed by this. Now this is a transformer which I'm just using the primary from. I'm using that as an inductor. So positive comes out of this capacitor, then into the primary of this transformer, then out again and into this capacitor where it's smoothed. And of course we got that DC output going along this wire here, and also to the connector. Now I should really label what these outputs are, but basically there's a 240 volts isolated AC output, there's a high voltage DC output there, and well, that's basically it. So I hear you ask, what about this resistor and this relay, which I don't think you could see earlier? What about those two? What are they for? Okay, so this resistor is a limiter because it's in series between this transformer and the rectifier. So it will charge up slowly and limit the current, which is good for things like preamplifiers and stuff like that. However, if I put the switch in this position, this resistor gets shorted out, so that might just as well be a straight piece of wire right there. So then the transformer's directly connected to this rectifier, and we get the full output of the transformer going into the capacitors and then out of the power supply. So that's off, that's on with low power with the resistor in the circuit, and that's on with high power with the resistor out of the circuit. And now what about the relay? Well, the relay is there to discharge the capacitors when this thing turns off, because when this transformer is on, we get 12 volts going across these two wires here into this diode and capacitor, which turns on the relay, and this capacitor is connected across the normally closed pins of the relay. So when the relay comes on, those pins open so this capacitor can charge up, and when the power's turned off, the relay deactivates so these contacts close and the capacitor discharges through these two resistors. Alright, time to take some measurements. So I'm going to turn this on and you'll see the voltage is about to climb. There we go. This is measuring the DC output, so that resistor there, I'm not going to touch it, but that resistor there is limiting the quickness of how much it charges. So I got a bit of a cold, so I'm not really able to think straight at the moment. It's still climbing. That will get up to about 300 and something volts at the thing. My train of thought is really gone. That will get up to about 300 and something volts with no load on it. So let's take a measurement of what we've got on the isolated AC. Let's get my meter in there. We have about 234 volts. Anyway, I put the meter back onto the DC. Make sure the range is on hundreds of volts so I don't blow this thing, so I don't blow the auto ranging of this out. Okay, there we go. I connected it the wrong way around, but it doesn't matter. So we got about 313 volts and still climbing. Now when I turn this off, you see the voltage drops quite quickly. It's got those 300 ohms worth of resistors discharging the capacitors. So that works pretty well. And that way, you see, good thing about that is discharging the capacitors that way. I mean, I could have just put a resistor across the capacitor and have that discharge the capacitors when this thing is not in use, but the thing is, I want this thing to be as hum-free, as ripple-free as possible, so I did it that way, which I think is a lot better. So anyway, rambling on here, and I haven't even described what this thing is for. Well, this is a little switch mode power supply that I made, and that's for the filaments of the tubes. On this side here, this is the 6 volt output, this is the 12 volt output for the different types of tubes. This is the ground, and I can actually use the output of that second transformer to power this power supply. And that way, as you can see, it's connected up to the AC output, and that way it's completely isolated. And we got 6 volts there. I don't know how well you can see that. See 6.49 volts on there, and just over 12 volts, well, just over 13 volts on that side. So that's working really good. So let's take a little look inside the switch mode supply. Let's get these wires out of the way. Some purists may think that this is blasphemy, using a switch mode supply in part of a tube circuit. But I don't care. Let's pull out the actual supply itself. And this is what we have inside. These came out of a couple of wall wart supplies. Now this one you may remember from an older video. This one I modified. It was originally a 5 volt supply. This is now a 6.4 volt supply. I was originally going to go for 7 volts, but when I was experimenting with it, got it to 6.4, so I decided I'd just stick with that. So yeah, it's a nice steady voltage. Now if the camera would just stay still. And this one here is the 12 volt supply, or supposed to be a 12 volt supply. I don't see any sign of any kind of feedback circuits. I mean, there might be something on the other side of the circuit board, I can't really remember. But there's only one output capacitor, no inductor. Yeah, so this one isn't even regulated, because you saw the output voltage is 13 volts and it should be 12 volts. So yeah, put whatever load that was originally going to power it, that would have brought it down to 12 volts, but it's good enough for my needs. This is the schematic of the power supply, well, the high voltage power supply for the plate. This is the main transformer here, and as you can see, the 12 volt goes into this capacitor, diode and capacitor to energize this relay coil. There's probably still quite a lot of ripple on that relay coil, but not enough to make it de-energize. And that output of that transformer also goes into this other transformer. So it stepped down to 12 volts by this transformer here, then it's stepped up to mains voltage again by this transformer here. Here's the 10k resistor that can be switched in and out of the circuit. You can see the switch at the bottom there. Then there's the rectifier that goes into this capacitor to smooth it. Then the filter. Don't know how many microhenries or millihenries or whatever henries that is, so I've had to leave that out. I've had to leave that unmarked. And then into one final smoothing capacitor, then that goes out to the circuit. So, when this transformer turns on, this relay coil gets energized, which opens the relay contacts, so this capacitor can charge, along with this one here. And when the power's turned off, this relay coil will de-energize, these contacts close, the capacitors, both these capacitors, get discharged through this resistor here, and within seconds it's safe to handle. So, putting two ordinary mains transformers back to back makes a pretty good tube supply transformer. But wait, some of you are saying, I live in a 120 volt area. There's no way I can do this. Yes, there is. All you need is a different kind of rectifier. The voltage doubler. And here is exactly the same circuit modified for 120 volt use. And as you can see, replaced that bridge rectifier with a voltage doubler. And that will work just as good. It's basically two half-wave rectifiers put together, because this capacitor gets charged up through this diode here, and this capacitor gets charged up through this diode here, and together we get the same output voltage, or very similar, the 240 volt version. Okay, so now I'm going to do the demonstration of the voltage doubler. So I've got two transformers here. I know they're not identical transformers, but the point is, we'll get about 120 volts AC out of this one, or should do anyway, because I've got this transformer feeding this one, you know, the low voltage output of this one, going into the low voltage side of this transformer, and then using the 120 volt tap from this transformer, we can measure that on the meter. So, plug this in, and I can find it. Alright, there we go. So, okay. Well, it's a bit difficult to see what it says on the meter, but trust me, that says about 107 volts. So, a little bit lower than what we want, but in the ballpark. Anyway, I'll just unplug this so I don't shock myself while I'm doing this. I'm gonna now connect up the voltage doubler, or voltage doubling rectifier, or whatever you want to call it, and see what kind of voltage we get off that. And remember, this is exactly the same as this. Now, put my meter onto DC. And we'll measure the voltage that we get across these two capacitors. Let's plug in. And my meter's auto ranging for some reason. I thought I'd turn the auto range off because I don't really want to blast the auto range. But as you can see, we're getting way more than 160 volts or whatever it was. 269 volts and still climbing. And remember that supply that I made, when you put a load on it, the voltage will go down a bit. So this is the unloaded voltage, basically. And as you can see, it's working pretty good. I don't know what that's going to actually come to, but that would actually be a little bit higher if this transformer was putting out the full 120 volts. But you get the general idea. So there you go. Anyway, that's just about it for this episode of Cool Dude Clem's Electronic Workshop, and, well, this episode of Tube Time on Clem's Electronic Workshop. On the next episode, what shall we do on the next episode? Magnetic cartridge preamp, maybe, using valves, or maybe a valve power amplifier, using one of these triode-pentode combinations? I don't know. Right, well, welcome to Tube Time, episode 5! Welcome to Tube Time on Cool Dude Clem's Electronic Workshop. Anyway, the votes have passed and you asked for it, or the votes have passed and you asked for it, so going to make a power amplifier using one vacuum tube. And oh god, my camera's glitching out again. I'm charging the battery for my other camera, so when that's done, we'll switch over to that. Today we are going to make a power amplifier using this one tube, and obviously a couple of resistors and capacitors as well. Now you might remember in one of my previous videos I made an amplifier using a separate triode and pentode. Well, this thing has the triode and pentode built into the same package. We have the triode over this bit here, which is this little bit here, and the pentode bit right there on the other side. So pentode on the left, triode on the right. Just seeing if you can make out the actual little individual windings there of the screen. I mean, of the control grid, but of course it's not. I don't think it's going to focus at this length. So let's take a look at the parts we're going to use. Obviously there's the valve. We're going to need something to connect this to a speaker, so output transformer. Going to need to be able to adjust the gain, so potentiometer, and of course various capacitors and resistors. I think my webcam is actually designed to behave on hearing that it's going to be replaced with another camera. So anyway, this is my design that I'm going to go with. And the tube I'm using is a 6 something 5 something. No idea what those characters are because I don't speak a single letter of Russian. So that means I couldn't look up the tube to find out the pin layouts or anything like that. But thing is, the person who sent me the tube, and thanks once again, also included a datasheet of an ECL85, which I think is the same tube. So anyway, I'm going to build up this whole circuit here, test it, and probably have to tinker with it to get it to work properly. So anyway, going to go and build this now, and I'll be back with it built, and we'll see how it works. We'll see how well it works. Okay, I've made it. Looks like a huge mess of wires at the moment. And it sort of works and it sort of doesn't. But mind you, I didn't expect it to work perfectly first time. And I'll give you a demonstration of how it sounds. I've got it hooked up to this speaker right here. And we're going to play something from the reel-to-reel. Well, I'm going to play something from the reel-to-reel. And play. Well, it is a valve amplifier. Yeah, I recorded some stuff from Team Fortress 2. Okay. It's freaking loud. Volume control works. Alright, let's stop that. Don't know if I'll get into any copyrights for that. It's hard to tell what you can play and what you cannot play on YouTube just lately. As you probably could hear, it's fairly distorted. But I think I know the problem. I'm also using my Jello Vision camera because I've just charged the battery for that so I can... So that's why the picture's not all going like this and stuff. Now, can you see the meter? I don't know, something about cameras. They have an inability to see an LCD screen. See if that any better? Yeah, it's sort of better, you can see it. So anyway, I decided to probe the supply voltage which comes in here. And look what we have. We only have about 83 volts supply. This is the main filter capacitor. Let's see what voltage we got there. We only got 115 volts there. Then after the choke, there we've got this capacitor here. It's gone down to about 79 volts now. It's crazy. The filament supply still seems to be quite happy though. Well, actually that's gone down a little bit as well. I was getting about 6.1 volts there. I'm only getting about 5.5 volts filament now. I'm surprised that this thing is actually working at the voltage it's getting. Because if you remember, that's being powered off the isolated AC. And we're already getting 94 volts. What is going on? I'll tell you what's going on. These transformers cannot handle it. I'm gonna have to make a better power supply. I'm surprised that this thing is even functioning on a voltage that low. I did hear it whine a little bit while it was starting up, and it's never done that before. I mean, this thing is probably working overtime trying to get the voltage to what it should be. Right, well, I've upgraded the power supply. I've put in that ancient transformer that's specifically suited to power up valve circuits are now getting a lot more power. I've also replaced the choke with this much bigger one. Yes, I'm still using a transformer as a choke, but we get much more output voltage. We're now getting about 308 volts across that capacitor. I don't know if you can see that. Again, camera's weakness for seeing meters. And across the final output capacitor, getting about 261 volts, so much more voltage. However, still got a few bugs to work out. Now, I've got some of Cave's messages from Portal 2 on here.
Welcome to the Enrichment Center.
Well, Cave, you sound terrible.
Making test participation mandatory for all employees, the quality of our test subjects has risen dramatically.
Yeah.
Employee retention, however, has not.
Yeah, it's still sounding pretty fuzzy. Okay, I'm just going to move this transformer because that's getting a bit... There we go. Not going to touch it because that transformer does get pretty hot. Not quite as hot as this thing gets though. Doesn't red plate though, which is a good sign. Or at least I don't see any signs of any red plating going on, so I think we're okay in that department. Of course, the camera cannot see anything at all now. Turn the lights out. Don't worry, the filament actually looks quite bright in real life, but on the camera it's very dim. I don't know why. The first rule of finding out what's wrong with electronics: thou shalt test voltages. So this is our supply voltage coming in right here. About almost 260 volts. That's absolutely fine. Alright, let's see what voltage is going to the screen grid. 169 volts. That doesn't seem to be too bad. Right, so let's see what voltage is on the plate of the triode part. 45 volts. Alright, let's see what we got on the plate of the pentode. I'm trying to do this, putting myself in a weird position so my hands don't get in the way. Making sure I put my thing across the right wire here. Alright, so we got 139 volts. That would explain why this little transformer's getting pretty dull. Why that transformer gets pretty warm. So everything seems to be okay. Right, well, let's test our bias voltages. And I can simply do this by measuring across the cathode resistor. So this is the cathode resistor of the pentode. Let's see what we got. Well, that's a little bit higher than I expected. We've got 28 volts there, so that resistor's going to get pretty toasty. Good thing I put a 35 volt rated capacitor there. Alright, so we got about 28 volts of bias on the pentode's grid. Let's check the triode. Let's see what we got there. And, oh, less than a volt. Well, that might explain it. Should have about at least 2 or 3 volts there. And go less than a volt. Should be higher than that. Okay, so that could be the problem right there. Could be a problem with the bias in the triode section. Okay. Alright, what I'm going to do now is I'm going to inject a signal directly into the pentode's grid and see how that sounds. Okay, so this is the line out from the reel to reel. I'm just going to put this directly onto the middle pin of this variable resistor, which goes to the control grid of the pentode section. So strangely enough, I'm not hearing anything. It's weird. Should hear something. I'm going to just reduce the amount of resistance there. Okay, that's rather odd. I'm not hearing anything whatsoever. Or maybe it's not so odd, considering that I'd actually plugged this into the line in instead of the line out. So, let's try again, and already my camera's batteries are running out. I only charged this yesterday, and I haven't filmed that much with it.
Make life rue the day and thought it could give Cave Johnson lemons. Do you know who I am? I'm the man who's gonna burn your house down with the lemons. I'm gonna get my engineers to invent a combustible lemon that burns your house down.
Okay, well, it definitely sounds distorted there, so I think we know where the distortion is coming from now. It's in the pentode section. My guess would it would have been in the triode section, considering that the bias is a little bit off. But no, it's in the bigger section of the tube, so I've got to find out what's causing that, and maybe we can bust this thing. Well, I was thinking that maybe we've got a bit too much current going through this thing, so I've added another resistor and capacitor in line with the one that's connected to the cathode of the pentode side, so we've got about 940 ohms worth of resistance between cathode and the ground. So I have now 40 volts at the cathode of the pentode section, and on the transformer got about 206 volts. So that transformer should run a little bit cooler now, because it's not got so much voltage across it. And all that aside, playing the tape, it's still
Cannon of the human race. Here I go. And I am
distorted.
Continue testing. Pure Intellect Cave here. Not to brag, but while you were cat-assing that last test, I rewrote the collected works of everything ever. If I gotta read this garbage for eternity, I might as well improve it.
Yep, I talk garbage as well. Anyway, I'm not licked yet. I thought the first thing I would try is a different output transformer, and what do you know? Sounds about 100 times better. No more distortion. And for some reason the battery on my camera is just going up and down at random. Okay, so this is the transformer that I was using before, which is still hot from its previous run. Now this transformer, this one, has a primary of about 1,000 ohms. Okay? However, I tried it with one of these doorbell or boombox or whatever you want to call it transformers, and this one has only about 400 ohms primary, yet it works about 10 times better. I think this tube likes to be put under stress. This is the final design. As you can see, I've got everything all nice and soldered up now, because before it was going slightly in the background, possibly because of tons and tons of loose connections. So anyway, we've got about 960 ohms worth of resistance there for the cathode resistor of the pentode part of the tube, using a 470 microfarad capacitor for the pentode section's cathode resistor. I know it's getting a bit confusing here. I had to stop and think about that myself, actually. I've also increased the cathode resistor for the triode part. I've increased that to 4.7 ohms. 4.7 kiloohms. So it should have a bit more bias. One of my peeps, one of my subscribers, suggested I should make a speaker out of one of these enclosures I have. So I have gone and done that. Put a speaker in, even added a bass reflex port. We'll see how well that works. Oh, and for those of you who want a closer look up at the power supply and the modifications I've done to it, well, here it is. You might notice that this transformer is still in there. Now, all that's doing is the relay, and nothing else. Because this transformer's primary is connected to the mains the way it normally would be. Well, it's connected up to the switch, but So we have the output from this transformer instead of this transformer, and everything else is pretty much the same. It's on and powered up, and I can still hear some static coming from the speaker, even though I've soldered everything in. It's kind of unexpected. Don't know if you can hear that. You know, it's hard to find something that I won't get, where I won't be had for copyright. Got this really old record on the turntable here. God only knows how old it is. It looks like a 78, but it's actually a vinyl 33. So, let's see how this turns out. Playing the second song in. Oh wait, that one's a bit depressing. Let's go to the third one. Yeah, that's better. Okay, now let's go to the amplifier.
When will you be near me, darling? Won't you make it soon? If your heart can hear me, darling, won't you make it soon? Every star above me knows we shouldn't waste that moon.
Well, I think that sounds pretty good.
If you really love me, darling, won't you make it soon?
Let's try to adjust the bass reflex port.
Will you come to me to stay unworried, watching every lonely day slipping away? Come and hold me close, and then I'll never know that loneliness again. Never again. So please, I need you near
Right about
me,
there.
darling, won't you make it soon?
And of course you couldn't see what I was doing.
Hear me, darling, won't you make
I was doing this. See if it sounded better with the bass reflex covered up or not.
When will you be near me, darling, won't you make it soon? If your heart can hear me, darling, won't you make it soon? Every star above me knows we shouldn't waste that moon.
Well, okay, I think... Alright, let's just stop this now.
Love me, darling, won't you make it?
There we go. Well, I'm going to say, apart from the unexplained static noise that I really have no idea where that's coming from, it's a pretty successful experiment. Let's turn this off. Now this is kind of weird. So when I turn this off, it makes a bit of a weird noise. There we go. Don't know what it is that causes that little squeak there, but yeah, whatever. Well, okay, so here is my final design. As you can see, it's almost identical to what you saw before, except of course there's those two resistors I changed. I mean, this one here, which is now 4.7k, and this one here, which is 960 ohms, which I made out of two 470 ohm resistors. And well, there is my single tube amplifier using a triode pentode combo. So anyway, we're just gonna let the thing speak for itself. Anyway, that's just about it for this video, so just gonna wrap a few things up. Still got a little bit of that strange static. I've absolutely no idea what's causing that. I also decided to put a 1k resistor between the potentiometer and the grid of the pentode. Even though this circuit is my own design, I saw that in a few other circuits that used this, so I decided to do that myself to see if, well, just to see if it would make any difference, but it doesn't seem to. Anyway, the other strange thing is that the grid on the pentode side should be at 0 volts, but when I measure it, as you can probably see, we've got about 44 volts, and that's should be at 0, or very close to 0. So anyway, I'm just going to take some final voltage measurements so you can see for those of you who are curious, so we can see what's actually going on. So the supply voltage of my improved power supply is about 255 volts, more or less. On the suppressor grid, again, this is in the pentode section, we've got about 200 volts. 200 volts. The plate voltage seems to be a little bit high. We've got about 10 to 20 volts less than what the supply voltage is. So I may reduce the cathode resistor and so I can get more current flowing through the tube. So I get more current in the output transformer. But for the most part it's working, so I might just well leave that as it is. Anyway, moving on to the cathode side, the triode side. Well, the plate voltage is about 63 volts, so that's pretty good. Anything between 50 and 150 is, as they say, in the ballpark. We got about 1.3 volts at the cathode. Still not quite as high as I'd want it to be, but increasing that resistor to 4.7 kiloohms has definitely improved it. It works, so I'm not complaining. And the grid is right on 0 volts, right where it should be. Or almost 0 volts, maybe. Just a couple of millivolts. Anyway, that's it for this video. And yes, you've been listening to me talking through this amplifier. Well, recording for me talking through this amplifier. But anyway, that's it for this video, and like I always say, until next time, goodbye.